All right, hello everyone. Today we are going to continue our gas laws. So far we have Boyle's law, Charles' law, Gay-Lussac's law, and the combined gas law. So now we're going to add a fifth law, which is called Dalton's law of partial pressure. This tends to be one of the easier laws of the gas unit. Basically what it says is that the sum of all partial pressures, so let's write our definition down first. So the sum of all partial pressures equals the total pressure of a container. So if we look at this figure right here, so we're going to say that this is one container. And you'll notice that in the container there are three different gases. Each of those gases are going to give a partial pressure to the overall pressure. So they're going to each give their own specific part. So remember that pressure is measured in the force that these molecules hit the wall of the container with. So they're all going to have slightly different pressures because they're all going to be moving maybe at slightly different speeds. They're going to have different masses. So for example, maybe the red ones are going to have a larger mass. The green ones are going to have, a little smaller. The blue ones are going to be even smaller. So they're all going to have these partial pressures that make up a whole. So this whole container is our total pressure, where each type of molecule, so let's say oxygen and helium, are going to then contribute to the part of the total. The equation is very simple. So the equation's right here. It's the total pressure, so that's what PT stands for, total. So PT stands for total pressure, is equal to the sum of the different parts. So for this one, it'd be the red plus the blue plus the green. That would be P1 plus P2 plus P3. So the different parts that make up the container. The dot 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 is because you can have as many gases that are present in the container. So it's not limited to only 3 partial pressures. You can have 7 partial pressures, 10 partial pressures. So every type of gas that's in one container is going to have its own partial pressure. So we'll do an example together. So it tells us that a tank contains 3 gases. So we know that we have a tank, and in this tank we have 3 gases. We have carbon dioxide, carbon monoxide, and we have hydrogen gas. So the total pressure of this entire tank is 434 torr. So this entire container has a total pressure of 434 torr. It tells us the pressure of carbon monoxide is 112, and hydrogen is also 112. So we know that carbon monoxide, hydrogen gas are both 112. So we're trying to figure out, what is the pressure of carbon dioxide? Well, we know that total container has a total pressure of 434. So all 3 of these molecules exerting force on this container is going to give a total pressure of 434. So we need to figure out, well, what is carbon dioxide's pressure here? So we're just going to plug it into our equation. So we know our total. So up here, PT is 434 torr. Okay, and all our units are in the same unit, so we're good. We don't have to convert. This equals our pressure of P1. Okay, so I will just pick P1 as being P carbon dioxide. So I don't know that one, so I'm just going to keep that as PCO2. Okay, the next one we know is carbon monoxide, which is 112. All right, and we know the next one is 112. And then just a reminder, as we're subtracting and adding, sig figs matter about the decimal place. So when we go through and we add this, all of our numbers will be with no decimals. So we go and we solve this. So we do 112 plus 112. So we add these together, subtract from both sides. Okay, so we end up getting 224. So you subtract 224, because that's what 112 plus 112 is. And again, we're subtracting because they're all being added together. So we want to do the opposite of it. So our pressure of our carbon dioxide is going to be 210 torr. So when we subtract 434 from 224, we know that our pressure of our carbon dioxide would be 210. We can always go back and check our work and make sure that all our partial pressures add up to the total pressure. So again, our partial pressure should add up to our total pressure. All right, so we're going to try one more together. So this one, it tells us we have a tank that contains 4 atm, okay, of nitrogen, 9 atm of oxygen, and then it contains 12 atm of helium, and it's asking what is the pressure of the tank. So this time, it's asking what is the pressure of the tank. So we know in this tank, we contain nitrogen, oxygen, and helium. We know nitrogen is 4 atm, oxygen 9 atm, helium 12 atm. And it's asking, well, what is the total pressure that all three of these molecules are exerting on this container? So what would be the total pressure in this container? So we know our P total is our unknown. That's our X. That's what we're trying to solve for. So all we're going to do is take all three of our partial pressures, which are what the container is made out of. We're just going to add them. So we know we have 4 atm for nitrogen, plus our 9 atm for our oxygen, plus 12 atm for helium. So that means that this container is going to, remember, we look at decimal places, so our entire container is going to have a total force of 25 atm. So when we're doing this, again, you just have to keep in mind decimals. Okay, so we have our correct number of sig figs. So again, all you're doing is you just have to figure out which one's the total pressure. Check your units. These are simple because they're all in ATM. So we don't have to do any conversions. If they weren't, we just have to make sure they match. And this is just our final answer. So again, Dalton's law seems to be a little easier. So I want you guys to try doing example 17 for your homework. And so this problem right here, the blast furnace example. And we will go over this one in class, so come with any questions. See y'all tomorrow.